universe, a vast space with a scale beyond imagination. The estimated number of stars in the universe is greater than the number of grains of sand on all beaches combined. It is a number that challenges the limits of human understanding. However, despite that, the universe is not truly as bustling as we think. In reality, the universe has an extremely low density of matter. If each star were shrunk to the size of a grain of sand, the average distance between them would be about 8 kilometers, nearly equivalent to the height of Mount Everest. That number corresponds to 4 to 5 light years on a real scale. A distance humanity could never overcome with our current capabilities. The fastest cosmic object humanity has ever built, NASA's Parker probe, would take about 7,000 years to cover this distance. And remember, that's just the distance from us to the nearest star. The nearest galaxy is hundreds of thousands of times farther. Faced with such unimaginable distances, humans seem trapped in an invisible cage from which we cannot escape. All dreams of exploring the universe are limited by the laws of physics, as if the universe is trying to challenge humanity. Nevertheless, we have not given up. Science and technology may be limited, but imagination is not. Based on physical theories combined with imagination, this ship has the ability to take us to the edge of the universe. This journey is sure to hold many interesting things. What will happen to us on such a journey? At the edge of the universe, what awaits us? To allow the entire crew to prepare, the ship will take off in the next few minutes. Journey to the edge of the universe. First, I need to introduce our ship a bit. This is a spacecraft beyond anything humanity has ever built, because it originates from imagination. The ship can accelerate with an acceleration slightly greater than gravitational acceleration for an infinite amount of time. For those who don't know, gravitational acceleration is denoted as g and has a value of about 9.81 meters per second squared. A ship accelerating uniformly at 1 g means that for every second that passes, its speed increases by 9.81 meters per second. In this case, our ship has an acceleration of 10 meters per second squared. After I finish this sentence, we have already spent 40 seconds since departure, so the current speed has also reached 400 meters per second and will continue to increase. Let's temporarily set aside the technical issue of how a spacecraft can accelerate for an infinite amount of time. Let's assume it. Additionally, the ship also possesses the ability to resist all types of radiation or any collisions along its path. Do you know what it? This also depends on what type of spacecraft you're on. With our ship, everything seems relatively comfortable. With an acceleration of approximately 1 g, you won't experience the floating in space like in science fiction movies. The gravity inside the ship is equivalent to Earth's gravity. All activities occur as normal. A ship that continuously accelerates may seem slow at first, but over time, its speed accumulates and grows. After just about 2.5 hours, we will fly past the moon. And after 1.5 days, Mars will be left behind. And then, guess what? Just 3 weeks after departure, we have already left the solar system. At this point, the ship is moving at a speed of over 65 million kilometers per hour, about 6% of the speed of light in a vacuum. That's mission to the moon back in the day, but still not fast enough for Einstein. Remember this information, as it is very important for the next part of the journey. As soon as we leave the solar system, we will head toward the star closest to Earth in the universe. You can try searching for Alpha Centauri for more information before we arrive. The light from the star system is becoming clearer, and the sun has faded, now just a small dot outside the window. In the next few years, there will be almost nothing special, time will just pass by. The only thing changing is that our speed continues to increase every day. Now, direct conversation with your friends and family on Earth is impossible because the time for radio signals to travel back and forth is too long. However, your loneliness is somewhat alleviated by news, culture, sports, and scientific discoveries. Still continuously updated from Earth, albeit with a slight delay. It has been 15 months since the journey began, and our crew celebrates passing the 1 light-year distance. But it. Now we have covered part of the distance to Alpha Centauri. But in terms of time, we have completed 1/3 of the journey. Because the longer we travel, the more our speed increases. Another important milestone we have passed is that the current Lorentz factor has exceeded the number 2. Wait, what is the Lorentz factor? According to Wikipedia, the Lorentz factor is the factor used to describe the dilation of spacetime. Proportional to the object's velocity, denoted by the letter gamma. The specific calculation formula you can look. In the above formula, gamma is the Lorentz factor, v is the velocity of the object, and c is the constant speed of light. This factor leads to the direct consequence of the special theory of relativity, which I just mentioned, describing that as the velocity approaches the speed of light, the observer will see the moving object shorten. And time inside the spaceship will also pass slower compared to the observer. For example, in this case, the time since departure for people on Earth is 15 months. But for the crew's perception, it is not that long. Einstein's special theory of relativity is having a very clear effect on the ship and the crew. According to observations, we are moving away from Earth at 87% the speed of light. If nothing changes, the observed velocity will exceed the speed of light in the next 45 days. But according to Einstein's theory, a rigorously tested theory, nothing can move faster than light. Accordingly, all observers will always see objects moving at most at the speed of light. This leads us to puzzling physical phenomena. Why can nothing be faster than light? Suppose you are driving a car to chase the car ahead. You will see that car appear to move slower than its actual speed. If that car is going 100 km per hour, and you are going 90 km per hour, it will move away from you at 10 km per hour. But if what is ahead is a beam of light, it will move away from you at a constant speed. The speed of light, approximately 300,000 km per second, is fixed and completely independent of the observer's motion. And the light source, because the speed of light is constant, time and space must change. The extent of change, more or less, is expressed through the Lorentz factor. That is exactly what is happening to our ship. Observers on Earth seem to see the crew taking more time than our perception to reach the destination. Not only that, when the Lorentz factor exceeds 2, it affects the perceived acceleration of the ship from Earth's perspective. Observers from Earth will see us no longer accelerating at 1 g, but it gradually decreases until reaching the speed of light. Therefore, saying nothing can be faster than light is based on the observer's perspective. But for you and the crew, everything remains unchanged. The ship continues to accelerate and has actually surpassed the speed of light long ago. You can perceive this more clearly by looking out the window. The light from the sun dims much faster than you think. Figuratively, as we approach the speed of light, we become more separated from the rest of space-time. But accelerating forever is not a good idea, because we do not have an infinite energy source. At some point, you will need to decelerate, stop, and land to explore the destination. This process also requires a huge amount of energy, difficult to meet. Therefore, we can calculate to decelerate the ship with a negative acceleration of 1, meaning each second the ship will reduce its velocity by 10 meters per second until it comes to a complete stop. To achieve that, we will begin decelerating right after reaching half the distance. Returning to the initial journey, we arrived at Alpha Centauri, which is 4.4 light-years from Earth. If a beam of light departs from Earth, it will take 4.4 years to get here, but the time on the ship is only 3.5. You don't need to worry about the ship violating relativity, because for observers on Earth, the actual journey has taken 6 years since the start. You can comfortably spend a few weeks exploring this new planet, then board the ship and return. The return journey proceeds similarly to accelerate at 1 g to the halfway point, then gradually decelerate with a negative 1 g acceleration until reaching. When you return home, about 7 years have passed for you, but for everyone on Earth, it has been 12 years. Timing ISN. Alright, now I want you to pay closer attention to the detail that the ship decelerates each time it has covered half the journey. At that moment, it was 2.2 light-years from Earth and occurred 1.8 years after the start of travel for the crew. The velocity at that time was 95% of the speed of light relative to an observer. A heated debate began among the members with two differing opinions. Finally, everyone agreed that we no longer want to land on Alpha Centauri. We will utilize this ship to venture further into the universe. The journey is divided into 4 phases: acceleration on the outbound leg, deceleration on the outbound leg, and acceleration on the return leg. The next milestone we want to surpass is about 30 light-years, exiting the boundary of the local interstellar cloud where the solar system operates. To achieve this goal, we want to surpass a certain condition of this ship. We will spend 13.4 years on the ship for the round trip, but when we return, our children will have aged nearly 70 years. It leads to strange reunions, as you see in the movie Interstellar. Of course, we don't stop at 30 light-years. After crossing that boundary, the next thing we face is a local bubble, originally named the local bubble. Spanning over 300 light-years in diameter, we will spend 22 years of ship time to complete the round trip. But by the end of the journey, Earth will have experienced a long 600 years. We will likely find it very difficult to adapt to the world's changes. How many people will remember that 600 years ago, a crew left the planet to venture into the vast universe? 22 years is a relatively long number, but we will probably still be quite young. If the crew wants to contribute more to this mission, we can even consider leaving this spiral arm of the galaxy, the Orion arm. Think it. The round trip to the Orion arm will only take about 31 years on the ship, and we can still accelerate continuously. We will reach maximum speed in the 8th year and end the outbound acceleration phase. However, after 6.5 years of ship time acceleration, or looking out the window, you will see something very strange. A reddish object is appearing and growing larger day by day. At first, you might think you're experiencing a mirage, or perhaps encountering a relatively large number. But then you realize our current HESOLORANCE has reached 650. The cosmic microwave background radiation is thus gradually shifting into the visible red light set. In the final year of the outbound acceleration phase, we see this reddish space growing stronger until reaching maximum speed. The ship thus attracted the attention of the number, and the accelerating ship has become continuously accelerating. The ship thus attracted the attention of the universe itself. Going beyond the Orion spiral arm to the galactic disk is not a bad idea either. Over 100,000 light-years, that unimaginable number will be completed after more than 20 years. With 41 years for a round trip to the galactic disk, we will be over 60 years old when we return. Meanwhile, Earth will have witnessed millions of years passing. Can you imagine how humans will change after another million years? This world will probably be very different. We can refer to ideas about the future world from scientists at NASA's Ames Research Center for easier visualization. First, after a billion years, Earth seems no longer sufficient to provide living space for humans. Therefore, large space stations in orbit are a rather perfect choice. There are three potential design models for future space stations, including the vernal sphere, the toroidal settlement, and the cylindrical settlement. The capacity of these space stations ranges from 10,000 to 1 million people. They can rotate to create artificial gravity. The cylindrical settlement is the largest among the ideas, with large windows allowing sunlight to illuminate the interior landscape. This design is also called the O'Neill cylinder. People live on a curved surface like a glass palace, and they practice agriculture there. Light is reflected through windows near the poles. To solve the radiation problem, researchers use shielding, polyethylene, lead, or electromagnetic fields similar to how Earth's magnetic field protects us from cosmic radiation. Currently, creating oxygen in space is done through water electrolysis. NASA has also developed technology capable of absorbing CO2, abundant on planets like Mars, and converting it into oxygen and carbon. Some craters on the Moon with stable temperatures around 17 degrees Celsius could also be used as settlements. Most recently, scientists at Embark University in the UK have developed an energy source that could allow astronauts to live long-term on the Moon. The energy source is said to be a nuclear fuel cell, measuring 12 by 18 centimeters, powering the Vivo nuclear generator. This research could make space travel safer and more efficient, while also paving the way for ensuring energy security in extraterrestrial life. Over a span of 1 million years, it is very likely that the aforementioned technologies will be perfected to the maximum, ensuring the most comfortable life possible for humans. By the time we return, many things may be beyond our imagination. Plans to implement living in outer space while some nearby planets have already begun to be carried out from this moment. The American Space Agency NASA is using 3D printing technology to find ways to build houses on the Moon by 2040. The material is made from lunar dust, and ordinary people can also live in these houses. In 2022, NASA conducted Artemis I, the first mission in the lunar project. The spacecraft orbited the Moon and returned safely to Earth. The Artemis II mission will carry real people, including 4 crew members, on a 10-day flight around the Moon, scheduled for November 2024. The Artemis III mission will be conducted in 2025, when humans will land on the Moon. However, due to certain difficulties, if the mission has been delayed from the planned schedule, the Moon is still not humanity's final destination. According to NASA's plan, the Moon is only a stopover and refueling point for the journey to Mars. Currently, NASA is implementing a program to test living in an area with conditions similar to Mars in Texas, USA. 4 volunteer crew members playing the roles of NASA astronauts have been conducting this test since June of this year for a period of 1 year. Meanwhile, SpaceX, the company of billionaire Elon Musk, is building plans for humans to go directly to Mars to settle. Anyway, all are just hypotheses. There are countless possibilities about the world after a million-year journey that we cannot fully predict. Future Earth dwellers may use languages completely different from those we know today. And our ship's travel log will become a precious ancient document representing a past civilization. Beyond 60 years old, it may be the limit for some members, but there will certainly be those who are luckier. With an additional 15 years, meaning 56 years on the ship, we will be able to make a journey to another galaxy, the Andromeda Galaxy, and return to Earth. We lost some companions, but we witnessed another galaxy with our own eyes. 5 million years have passed on Earth. Perhaps we are the last remnants of humanity if something unfortunate happens. Even though humans are no longer here, the planet seems more beautiful than the day we departed. Biodiversity has almost recovered to pre-human levels. Various coral reefs stretch across the seas. Coastal cities have disappeared as nature reclaims the place that originally belonged to it. If we want to go further than Andromeda, we need to consider methods to extend lifespan. Here I can propose a few options for us to consider together. Scientists from the Mayo Clinic College of Medicine have found a way to increase the lifespan of mice by 35% without leaving too many side effects. If this ratio remains the same, the average human lifespan worldwide would increase from the current 71 or 95 years. Perhaps the secret of this technology is to remove senescent cells that cannot divide. In addition, the scientific method also delays the onset of age-related diseases such as cardiovascular disease, kidney failure, and cataracts. In fact, senescent cells appear everywhere in the body over time, including skin, muscles, and internal organs. When too much pressure is applied, these cells also stop dividing. In general, cellular senescence is a biological mechanism that functions as an emergency brake to prevent cell division, and it is often used by damaged cells. Although preventing cell division limits the risk of developing cancer, these cells become redundant if the emergency brake mechanism is activated. In addition, the immune system regularly removes damaged cells in the body when humans are young. Over time, this function becomes less effective. Damaged cells gradually accumulate inside organs and ravage the body as we age. More notably, these are cells related to dangerous diseases such as heart failure, arthritis, Alzheimer's, and cancer. With the goal of maintaining the body, removing damaged cells still works well in old age. Researchers conducted genetic mutations in laboratory mice so that they continue to produce caspase, a type of protein that plays a crucial role in the body, removing damaged cells. This protein only appears in response to another protein called P16, produced by senescent cells. This process of producing caspase was adjusted by scientists using a special drug, and middle-aged mice were injected twice a week throughout their lives. Subsequently, scientists discovered that as mice aged, the effectiveness of this method became more pronounced. Specifically, the lifespan of the mice was extended from 17% to 35%, and they remained healthier compared to other old mice not treated with the drug. Nevertheless, this therapy is not yet perfect. Some senescent cells have not been eliminated, including those in the intestines and liver, causing difficult-to-control damage. Currently, researchers have set a future goal of finding ways to completely eliminate senescent cells in the human body. That is certainly a much more difficult task than performing on mice. The ultimate result of this research process is to develop a drug with similar effectiveness in humans, hoping to eliminate about 60 to 70% of senescent cells in middle age. This research has attracted the attention of many investors. Unity Biotechnology has become the first investor for scientists developing drugs to combat the aging process. The dream of living to 100 years old is becoming increasingly practical. With new life-extending technologies, we can embark on a journey beyond the Milky Way galaxy where we currently reside. This journey is expected to last 67 years for 2 million people. The Milky Way galaxy is located within a Lagrangian supercluster, a region of space spanning millions of light years and containing tens of thousands of other galaxies. To venture beyond this space, you need a round trip lasting 76 years. At maximum speed during the journey, our Lorentz factor is approximately 250 million. And of course, both destinations lie within an acceptable time frame for age enhancement technology by removing aging cells. I cannot calculate how much the time dilation has grown when we return to Earth. The changes are clearly visible from space. The continents have shifted and are no longer in their original position. There are no plants, nor any animals left. We can't even breathe normally as we did when we left. During the time dilation period, the sun's brightness has increased by nearly 10%. This creates conditions for weathering on Earth to occur at a terrifying rate. CO2 has decreased to the point where plants can no longer photosynthesize. Without plants, there is essentially no life. If lucky, we might still find some simple organisms that could survive. Earth is truly taking its last breaths. This time returning, we all feel deep sorrow for our homeland that was once glorious in the past. So there's only one way to forget that sadness: never return again. Laniakea isn't the end of the universe. We can go even further. After all, time dilation has now grown so large that we can travel exponentially farther distances each year. By using a ship with 1g acceleration, could we reach the edge of the observable universe? Unfortunately, the answer is no. When distances reach billions of light years, the expansion of the universe clearly affects our journey. In 1998, astronomers used telescopes to observe distant supernovae to study the expansion rate of the universe. That's accelerating every day, as shown in the models we. No one understands why this happens. Some believe it comes from dark energy. Using different measurement methods, we can determine various boundaries in the universe. For example, the horizon is the maximum distance a light particle can travel since the Big Bang occurred, about 13.8 billion years ago. In simple terms, it would travel about 13.8 billion light years. But in reality, due to the expansion of the universe, that distance is actually much larger, up to 46 billion light years. Now, back to our ship. If we want to make a round trip across billions of light years, the expansion causes distances between regions to gradually increase, meaning we have to travel even farther. If moving within a region affected by gravity like a galaxy or supercluster, this doesn't happen because gravity counteracts expansion. However, when we venture beyond the supercluster, nothing protects us from the expansion of the universe anymore. With a terrifying formula as you see, the final number given is 8.3 billion light years. Yes, this is the ultimate boundary we can reach if we still want to return. Beyond this number, we are forever trapped in the void, simply because the expansion rate of the universe is many times faster than the speed of light. The final move of the chess game of fate: do you want to return or not? What if we decide this is a one-way trip and never return? What awaits beyond those 8.3 billion light years? The current answer is nothing. The spaceship is no longer a distance-traveling vessel but has transformed into a time machine. With 200 years of continuous acceleration according to ship time, Earth time has passed 10 to the power of 411 years. This time is long enough that even protons theoretically could decay into nothingness and void. And finally, I can tell you that this journey has ended. We have reached the ultimate end, where there is no time nor space. However, remember that no conclusion is completely accurate at all times. Even science changes every day. Just a few centuries ago, people thought the Earth was flat, and the Sun and other celestial bodies revolved around us. Knowing that in the future, with just a few scientific advancements, the universe may not be as mysterious as we think. So we have just completed a special journey. The question now is, if everything ultimately turns to nothingness, should we expend effort exploring the universe? What meaning does that ultimately have? This answer probably must be left to researchers, because only they truly know what they're doing. Personally, I think humans may never achieve the journey we imagine today. But one thing is certain: humans always have enough ambition to push civilization further. To achieve that goal, space exploration must continue. Due to limited time, today's video will end here. Thank you all for your interest and attention. Hello and see you again in the next video. Wishing everyone a good day with your family. Please subscribe to the Dark Truth Files channel to watch the latest videos.